Hello, this is 7-3, multiplication properties of exponents. We're going to be talking about several kind of rules of exponents when we are multiplying things that have exponents. And again, I think that we've talked about some of these things before, but I did want to touch base here. Our main goal with all of these rules about exponents and negative exponents and zero exponents is for the purpose of simplifying exponential expressions. And this list here is everything that has to be true in order for something to be considered simplified, and that's what all these rules are used for. So first of all, there can't be any negative exponents, and that's what we were working on back in 7-1 with getting rid of negative exponents. You can also not have the same base appear more than once in a product or a quotient, and we're going to be learning some rules today to help with that. We can't have powers raised to powers. We can't have products raised to powers. We can't have quotients raised to powers. And numerical coefficients in a quotient can't have any common factor other than 1. And basically that big long description there means that you have to reduce any fractions that you have. Okay? So we're going to be working through in the next several sections on how to take care of everything on this list so that we can have completely simplified exponential expressions. The first thing we need to talk about is the product of a power property. And you only need to write down here the highlighted parts and again title it product of a power property. Okay, so the product of two powers with the same base equals that base raised to the sum of the exponents. And you can see that here a to the m times a to the n is the same thing as a to the m plus n. And if you like numbers more, 6 to the 7th times 6 to the 4th is the same as 6 to the 7 plus 4, or 6 to the 11th. Now notice that it has to be the same base, meaning, remember, base is this number here, the 6. So both of these have the same base, so we can add their exponents. So let's look at a few examples here. 3 to the 2nd times 3 to the 5th. Well, according to the property that we just learned, that's going to be the same as 3 to the 2 plus 5, which would be the same as 3 to the 7th power. Okay? Let's look at another one here, a little more complicated one. Notice here that I have two different bases. I have a base of 2 and a base of 3. So I'm going to group them according to their bases. So I have 2 to the 4th times 2 to the negative 2nd, and then I have 3 to the 4th and 3 to the 2nd. So here this would be 2 to the 4 plus negative 2 power, and this would be 3 to the 4 plus 2 power. So 4 plus negative 2 is 2, so this would be 2 squared, and 3 to the 4 plus 2 is 6, so 2 squared times 3 to the 6th. Okay? So that would be our answer there. Now sometimes they will actually figure out, 2 squared, we know that's 4. 3 to the 6th is a little more complicated. Sometimes they'll actually multiply that all out, but I'm okay. When we have powers, I would say more than 5, we can just leave it as it is. Just a couple more here with variables so we can get used to it. Again, I have a couple different bases here, so I'm going to group them. Q to the 3rd times Q to the 6th, and then I have R squared out here. So Q, that's the same base, so that's Q to the 3 plus 6, and then R doesn't have any buddies, so it's just going to stay out there. Well, Q to the 3 plus 6 is Q to the 9th, and then R squared. So that would be my answer there, Q to the 9th times R squared. I've gotten rid of having the two of the same base. Here I have all n's, so that's going to be the same as n to the 3 plus negative 4 plus, and remember, if there's not an exponent there, it's a 1. So 3 plus negative 4 plus 1. Well, 3 plus negative 4 is negative 1, plus 1 is 0, so this is actually n to the 0 power, and as we learned in 7-1, anything to the 0 power is 1. So my answer to that one would be 1. That leads us to a next type of problem here that you're going to run into. And this is just working a little bit on an application of the rule that we just learned. So light from the sun travels at about 1.86 times 10 to the 5th miles per second. It takes about 15,000 seconds for the light to reach Neptune. Find the distance from the sun to Neptune. Write your answer in scientific notation. So we're going to use this formula, which I'm sure you've seen before, distance equals rate times time, to figure this out. But we want to know the distance from the sun. We know that the rate the light travels is 1.86 times 10 to the 5th. And the time that it takes to get there is 15,000 seconds. So to figure this out, the first thing I'm going to do is I'm going to write 15,000 in scientific notation, which we worked on in just the previous section here. So 15,000 is the same as 1.5 times 10 to the 4th. So essentially here I have 1.86 times 10 to the 5th times 1.5 times 10 to the 4th. Now the cool thing about scientific notation is when I multiply two numbers in scientific notation, I can group the numbers. So I'd have 1.86 times 1.5, and I can group the powers of 10. This is where the property that we just learned comes in. So then if I do 1.86 times 1.5, I get 2.79. And then 10 to the 5th times 10 to the 4th, based on the property we just learned, is 10 to the 9th. So the distance from the sun to Neptune is 2.79 times 10 to the 9th miles. That's a long way. Okay, so when you come across those, that's what they're wanting you to work on, is how to multiply numbers that are in scientific notation. Now the next property is power of a power. And again, title this part power of a power. Write down the words that are highlighted, and then this little part over here that's highlighted. So when we have a power raised to a power, that's the base raised to the product of the exponents. So if I have a to the m raised to the n, that would be a to the m times n power. And again, if you like numbers better, if I have 6 to the 7th to the 4th, that's going to be 6 to the 7 times 4, which is going to be 6 to the 28th power. Let's look at a few examples here. So I have 5 to the 2nd to the 4th. So that's going to be 5 to the 2 times 4, which is 5 to the 8th. Okay. Here's another one. 4 to the 3rd to the 0. So that's going to be 4 to the 3 times 0. Well, 3 times 0 is 0, so 4 to the 0. And then again, anything to the 0 power is 1. So my answer to that one would be 1. Let's look at a little more fun one here. X to the 3rd to the negative 5th. So that's going to be x to the 3rd times negative 5. X to the 3 times negative 5. And then I still got this x to the 4th out here, but I'm going to deal with that later. So x to the 3 times negative 5 is x to the negative 15th times x to the 4th. Now the first property said that if I have the same base and I'm multiplying them, I add the powers. So this is going to be x to the negative 11th. Now I know that I can't have a negative exponent in a simplified expression, so this guy's going to have to go underneath 1. So this would be 1 over x to the 11th. And then it would be completely simplified. Okay? So if I have a power to a power, I'm multiplying the two powers together. Okay? And then the last property to talk about here is the power of a product property. And again, title this part power of a product property and write down the highlighted parts here. A product raised to a power equals the product of each factor raised to that power. So if I have a times b in parentheses to the n, that's the same as a to the n, b to the n. It's kind of like distributing the exponent, if you want to think of it that way. Or if you like numbers, 2 times 4 in parentheses to the third is the same as 2 to the third, 4 to the third. And you can see that they went ahead and multiplied that all out because those were pretty simple powers. So let's look at this one here. So the negative sign, it's not in the parentheses, so it's going to stay outside. And then I got 2 to the second, y to the second. Because, just like the property we just talked about, the exponent goes to each part of my product. Well, 2 to the second is 4, so I can go ahead and figure that out because that's pretty easy. So negative 4y squared would be my answer to that one. And now in this one, my exponent, or my negative sign, is in the parentheses. Okay, so that makes a little bit of a difference here. Negative 2 to the third. I'm going to put that in parentheses so I know that the negative sign comes with it. And then I got y to the third. Now negative 2 to the third is negative 8. Again, that's a pretty easy one, so I go ahead and figure that out. Negative 8 y to the third would be my answer there. Okay, now one that's a little more exciting here. As we do this more and more, you'll have to use the properties together instead of one at a time. So here I have a product, but both of them have exponents, and then that's raised again to a power. So we're going to have to separate this. So let's first of all apply x to the sixth to the second. I'm taking the exponent and applying it to each part. Y to the negative third to the second. Well then, power to a power tells me that this is x to the 12th and that this is y to the negative 6th. Well now, I have a negative exponent here, so that's going to have to go on the bottom. So I'd end up with x to the 12th over y to the 6th. And that would be my answer. So once we learn all of these properties, we'll start using them all together to make sure that we have completely simplified exponential expressions. Okay, so that's everything for 7.3. Let me know tomorrow if you need additional examples or if you have any questions.